There's the universe, the death of the Sun, the collision of the Milky Way galaxy with the Andromeda galaxy, and possibly the Big Rip. The telescope's camera has subtle changes in the way it captures images over time. NASA has just issued a startling warning. The Andromeda galaxy is on a direct collision course with the Milky Way. For years, astronomers have predicted this event, but new research from NASA suggests the outcome might be more certain than previously thought. While the collision of these two massive galaxies seems inevitable, what does this mean for our galaxy, and how will this cosmic collision unfold? Andromeda, also known as Messier 31, is about 2.5 million light-years away and moving towards the Milky Way at 68 kilometers per second. Earlier studies indicated a head-on collision leading to the formation of an elliptical galaxy dubbed Milky. Such galactic mergers were common between 6 billion and 10 billion years ago and have significantly influenced the structure of our universe. Led by Tilsala from the University of Helsinki, the new study highlights that uncertainties in measuring the galaxy's movements and masses, along with the gravitational effects of nearby smaller galaxies, could potentially alter the predicted outcome. The research used data from the Gaia and Hubble space telescopes to explore different scenarios. In our local group of galaxies, the Triangulum galaxy is another spiral galaxy located approximately 2.73 million light-years away in the constellation Triangulum. When added to the collision simulation created by NASA, experts increased the likelihood of a merger, whereas considering the Large Magellanic Cloud's orbit made a collision less likely. Within 10 billion years, if no merger occurs, the galaxies could simply pass each other, potentially disrupting and ejecting some of their outer regions into space. Despite the 50% chance of collision, any direct impact on our solar system would be minimal, defying ideas that intelligent life is so bizarre and rare that it only occurs under perfect circumstances. Future data from the Gaia mission may help clarify which nearby galaxies hold the strongest influence on this potential merger. If the Milky Way and Andromeda do collide, our solar system might be moved to one of the new galaxy's outer arms. This process would predominantly be orderly due to the ample space between stars and would create stunning trails of stars and new bursts of star formation. After 10 billion years, as the universe continues to expand, Milky will dominate our visible universe, with distant galaxies receding beyond sight. If the universe is expanding at such an alarming rate, as observed through the increasing distances between most galaxies, why is it that some galaxies, such as these two, are moving closer instead of drifting apart? To explain this, the expansion of space is a fascinating phenomenon dictating the movements of galaxies across the universe. This cosmic expansion influences galaxies differently based on their distances and gravitational interactions. While Andromeda and the Milky Way are moving towards each other, defying the general expansion trend, this is due to the overpowering force of gravity between them, a force strong enough to counteract the expansion of space on their scale. According to the laws of physics, if you can build a spacecraft that goes very close to the speed of light, you can shrink the distance to the Andromeda galaxy and the time it takes to get there by an arbitrary amount. The closer you get to the speed of light, the more you can shrink it. In contrast, some regions like voids experience faster expansion than dense galaxy clusters. Dark energy plays a crucial role, subtly accelerating the universe's expansion and impacting vast scales beyond gravitationally bound systems. This cosmic tug-of-war between gravity and expansion raises intriguing discussions about the universe's structural dynamics and future, especially concerning local groups like ours that may eventually merge under gravitational pull. But what if this cosmic collision happened tomorrow? Would all the stars and planets crash into each other? Could our solar system withstand such a massive impact? What mesmerizing spectacle would unfold from Earth? If the universe is so big, wouldn't every single potential situation happen in infinite numbers? It's infinite, or is it? In our observable universe, there are at least 100 billion galaxies frequently colliding. Large galaxies merge roughly once every 9 billion years, while smaller ones collide even more often. But wait, what about dark energy, the force that supposedly pushes the universe apart? For neighboring galaxies, gravity takes the lead, and Andromeda and the Milky Way are no exception. Both harbor central supermassive black holes destined to unify their star systems. Imagine a scenario where this monumental collision occurs tomorrow. Andromeda, still 2.5 million light-years away, spans a vast gap that cannot close in just one day. But let's assume the supermassive black hole at the Milky Way's center immensely increased its gravitational pull on Andromeda's black hole, causing the Big Crunch 4 billion years ahead of schedule. What would ensue? Firstly, the Milky Way and Andromeda, as spiral galaxies, would become entirely different, a unified elliptical galaxy. We could dub this new formation Milk Andromeda or Milkdromeda. As Andromeda encroaches on the Milky Way, our Sun and solar system might be pushed to the fringes of this newly formed galaxy, relocating 26,000 light-years further away. A best-case scenario is that we end up on the outskirts, while in the worst case, we could land in a galactic hinterland 160,000 light-years distant from Milk Andromeda's center. What about the stars in both galaxies? While the Milky Way boasts around 250 billion stars and Andromeda exceeds 1 trillion, they're all separated by vast expanses of empty space, making star collisions improbable. Instead, they would scatter into new orbits. Oh, and let's not forget our uninvited guest, the Triangulum Galaxy, M33, a smaller companion to Andromeda, adding to this cosmic mashup. From Earth's view, this event would be nothing short of spectacular, with the dazzling core of the newly shaped supergalaxy lighting up the night sky. Eventually, the supermassive black holes at the center of these galaxies would draw near and merge, creating a bright quasar at the galaxy's core, an astonishing display for any observer on Earth. Sadly, our planet won't endure to witness it. By the time Andromeda and the Milky Way collide, the Sun will have transformed into a red giant, consuming the Earth. In conclusion, the cosmic dance between the Milky Way and Andromeda highlights the intricate balance of forces within our universe, where gravity and cosmic expansion play out on a grand scale. While the possibility of their eventual collision captivates our imaginations with scenarios of unprecedented celestial beauty and transformation, it's a reminder of the dynamic nature of our cosmic neighborhood. Whether they merge to form Milkomeda or continue their paths without significant interaction, this event will unfold long after Earth's habitable days have ended. However, we may not witness such monumental changes.